Alright guys, so we're on to properties of waves. This is a review. Should be kind of quick because we just covered this unit. Okay. A wave is a transfer of energy created when a moving source creates a vibration, that back and forth motion, and there's no transfer of matter. Remember, I hit my desk, pieces of my desk aren't flying off, but I'm transferring that energy. Mechanical waves require a material or medium through which to travel, transverse or longitudinal. I came up down here, y'all. Let's go. Types of mechanical waves. The first is transverse. The medium moves perpendicular to the wave. So my hand is going up and down. The wave is traveling out this way. That is perpendicular. You know, math term. Hands going up, waves going this way. Swinging a rope back and forth or up and down. You're swinging your rope, but the movement is going that way. This one has a crest, which is the highest point, a trough, the lowest point, and a wavelength, which is the distance from a point on a wave to the same point on the other wave, either from crest to crest or trough to trough. Amplitude is the distance from the line of rest position to the crest. It corresponds to the energy in the wave. Bigger amplitude, more energy. So you have the line of rest. If everything in the ocean could be perfectly still, this would be the line of rest, and then the waves going up and over, that is creating the amplitude. Higher wave, more energy, because it's the same type. A transverse is a ocean wave as well. So here you go. You can see the displacement. This is what's moving it, the way it's traveling. You have the troughs, you have the crests or the peaks, amplitude, and the equilibrium. Remember, it wants to be perfectly calm. Second we have is a longitudinal wave. It moves parallel to the wave. Example is a slinky. So when I'm sitting here going like this, that is creating sound waves, but it's also creating, they're moving the same direction as the wave. Compression is the part of the wave where the particles in the medium are close together. Compression shorts, remember? Okay, they're pressed together. Press, the word press is in there. Compression, press together. Rarefaction is when part of the waves are their farther apart. They're rare. They don't want to be by anybody else because they're different, so they're farther apart. So in a longitudinal wave, wavelength is measured from tightest point of compression to tightest point of compression. They say that you could also do it from the loosest point of rarefaction. I don't usually talk about that. Rarefaction is where it's spread apart. Compression is where it's together. This is the direction it's moving. And these are the waves where someone's started the wave. Electromagnetic waves. That's visible light, UV, X-ray. It's all parts of the spectrum. Remember, there's 7 different types of waves in the electromagnetic spectrum. Sight. Okay, so this is a part where we did a little bit different. Sight is the components of the eye decipher light and the appearance of an image occurs. Sound is sound waves vibrate in the ear, which allows us to hear. Remember, we have rods and cones in the retina of our eye. Light comes through our eyeball, through the cornea, and goes to the back of the eye, and that's how we see a picture. Sound, it's going into our ear. There's 3 parts to the ear, the outer, the middle, and the inner. It goes into the outer ear, goes down, hits the drum, vibrates, there's liquid, and it sends a signal that we interpret as sound. Remember, sound travels faster. Light travels faster than sound. Sound travels fastest through a solid, slowest through a liquid, or slowest through a gas. So sound, when it's tightly packed, desk is going to travel faster than just the air, but the speed of sound is still very fast. Waves differ in how fast they travel and how much energy they carry. So the frequency is the number of waves that pass in a second. So if we measure this in hertz, 1 hertz is 1 wave per second. 5 hertz is 5 waves per second. 11 hertz is 11 waves per second. The frequency of a wave equals the rate of vibration of the source. So whatever is creating it. So if I'm creating a wave right now, and this is how slow I'm moving, and I do it 3 in a second, then my hertz is going to be 3 waves, or 3 hertz. Wave speed is how fast a wave is traveling. It's calculated wavelength times frequency. Okay, so how far is it apart by how many waves are passing in a second? And it can depend on what it's moving through. Is it going through a gas, a liquid, or a solid? So we have a wavelength of 10, a frequency of 3, then you would have 30 waves in a second. Wave behavior. How does it act? Okay. Reflection is it occurs when a wave bounces off a material. It hits and comes back. All types of waves can be reflected. Reflection does not change the speed or the frequency. It hits and comes back at the same speed. One of the ways we look at this is the mirror. When you see your reflection, it's coming back at you. There's only a reflection if there's light. The light waves is what's coming back at you. You don't see your reflection in a mirror if there's no light to let your reflection come back. When a wave is when it is reflected, it flips upside down. Example, sound waves causing echo. So it hits and it flips upside down and come back the other way. Refraction is the bending of a wave as it changes mediums at an angle. Okay, it hits examples like a straw. A straw appears bent because it's going through a liquid. But before that, it's going through a gas. Waves move at different speeds through different materials, so what I was just talking about. When a wave enters the new medium at an angle, one side of the wave changes speed before the other, causing the wave to bend. Also, what we looked at when we looked at a prism. The light's going through the prism, but it's bending, and then it bends as it goes out again because it's changing mediums. Objects in a water appear closer to the surface because water is bending around that object to look different. Think about the penny. Remember, you couldn't see the penny when you poured the water. You could see the penny because the light is bending it. And finally, diffraction is a wave bends to go around an object. How much a wave bends depends on the size of the object it is going around. So you're in the pool, you jump in the pool, the waves go out, they hit your friends and they go around them. Right? That's diffraction. The fact that you can hear me in another classroom, the fact you can hear other people in my classroom, that is all diffraction. There's little tiny gaps within the thing. If the door is open, you can hear a lot better than when the door is closed. It's a bigger opening. And the example is you can hear sound in other rooms. All right. That is all for properties of waves. If you have questions, comments, go ahead, let me know. And we'll pick up with the next one. Have a good one.